Okay, last section, 7.4 in chapter 7. We're actually skipping 7.3. All right, so we're going to learn how to calculate a test statistic, Z for proportions, to find critical values, Z naught, find rejection regions, and use a Z-test to test a population proportion. So when we collect qualitative data, we can use that data to test a claim. This can be achieved by doing a hypothesis test for proportions. So the formula for calculating the test statistic for a sample proportion is going to be that Z is equal to P hat minus P divided by the square root of P times Q divided by N. That's four different variables that we will be using. Okay, so let's define them. P hat is going to be the sample proportion. P is going to be the population proportion. So P is actually going to be from our claim. Q, I don't remember if you remember this from when we did proportions last time. It's 1 minus P. And then N is our sample size again. All right, so before you run the test, verify that the sampling distribution is approximately normal. So to do that, you're just going to take N, your sample size, multiply it against your population proportion, and that number has to be greater than or equal to 10. Or you can also take your Q value, multiply that against your sample size, and that should be greater than or equal to 10. Oh, it's not an or, you have to do both. So it has to meet both of these requirements. All right, so then the 8 steps to perform a hypothesis test for proportions with the words and the math. So the English. First things first, write your null and alternative hypothesis. You notice this next step never changes. So this is going to be where you declare what is your null hypothesis and which one is your alternative hypothesis. Then you need to identify your significance level. So this is going to be alpha equals, the number is going to change. Your alpha is going to equal to different numbers depending on what it is in your problem. And then we're going to draw the standardized distribution. Or not the standardized sampling. And you can use this normal curve because we already proved doing this proves that you're approximately normal. And you can only use this bell curve if you are approximately normal. There we go. Flipping that around to the back. All right. Fourth step would be to calculate your critical values. So you're looking for your Z naught, and you're going to be using the websites. Remember, I posted a video on how to use that website. And then number 5 would be to shade rejection regions. So once you have your critical value, you're going to go back to your distribution from step number 3. And then you're going to mark your critical value, and depending whether you're a left-tailed or a right-tailed or a two-tailed test, you're going to shade the correct region, rejection regions, and the unshaded region is your non-rejection regions. Okay, and then step number 6 is to calculate the standardized test statistic. So that's the formula that we just identified at the beginning. Z equals your sample proportion minus your population proportion divided by the square root of your population proportion times its complement divided by the sample size. And then your 7th step is you're going to decide to reject or fail to reject your null hypothesis. And sometimes your claim is not always your null hypothesis. So remember, you do this if your critical value, or if your z value right here that you get, and once you find your z value, you go and you put it on your graph. If it falls in the rejection region, which is a shaded region, then you reject your null hypothesis. If it does not, then you fail to reject it. All right, then this leaves you with step number 8, which should be familiar. You need to interpret the decision that you make in words. But it also needs to be in context of the claim. So this does not end with you just saying, fail to reject HO. Well, you have to interpret it back into words. And how did that have to do with the claim? Because we were trying to prove or deny our claim. Sometimes your claim is your alternative hypothesis. So you have to think carefully about that. If you reject your alternative, if you reject your null hypothesis, then you can say that you have enough evidence to accept the claim because your claim is your alternative and your null wasn't right. If you fail to reject your null hypothesis, but your claim is your alternative, then that means you have plenty of evidence to go with the other side, to accept your null hypothesis and to decline your claim. All right, so can the normal sampling distribution be used? To verify the normal sampling distribution can be used to test a claim about a population proportion. So on these next couple of ones, we're just gonna double check and that n times p is greater than or equal to 10, and n times p is greater than or n times q is greater than or equal to 10 is our thing. We're gonna double check that, make sure that's correct on both of these. All right, so on number A, we have p is equal to 0.278, n is equal to 1/10. So you need q too, and q is 1 minus p. So that would just be 1 minus 0.278, which would give you 0.722. So then you need to double check, is NP greater than or equal to 10? And is NQ greater than or equal to 10? So NP, N is 110, times P, which would be 0.278. This is actually going to give you 30.58, which is greater than or equal to 10. So we're good right there. If you need to check the other side, you do it again, is 110.27.722. You want your Q this time. Okay, well that's actually gonna give you 79.42 which then you compare it to greater than or equal to 10. Is it greater than or equal to 10? Yes, in this case it is. So then this is a good sample. And you would continue on. But remember, you got to check this before you can even do the 8 steps. Well, let's try this next one. Okay, so we know Q is 1 minus P. That would be 1 minus 0.79. Well, that's 0.21. So then we need to check NP, make sure NP is greater than or equal to 10, and then check NQ, make sure that's greater than or equal to 10. So the NP would give us 18 times 0.79, which is actually going to give us 14.04. And then you compare that, is that greater than or equal to 10? In this case, yes, it is. Then you check the NQ, so you would do 18 times 0.21, which is going to give you 3.78. And you ask yourself, is that greater than or equal to 10? No, it is not, because 3.78 is actually less than 10. So then this would be a big no. So you would say that's not a good sample. And you would stop right there. So whereas A was a good sample, you would continue on with your 8 steps. B was not a good sample, and if you don't have a good sample, then you can't use a normal distribution, and so then you can't use those 8 steps, so then that's where it would end. Now, if you're had we calculated NQ first and found that that wasn't, there'd be no reason to calculate NP. Once you get a no, it's a no, and you can stop right there. But since we were yes on NP, then we want to go calculate NQ. All right, so it's time for some examples. All right, so the AMA conducted research in 2017 and found that at least 24% of US adults are smokers. A random sample of 300 US adults were surveyed and 20% said they currently smoke. Is there enough evidence to reject the AMA's claim at your alpha equal to 0.01? That's what we're going to find out. So whenever they ask you if there's enough evidence, that's when you have to use those 8 steps. And we're going to be finding different things to use. All right, so starting with the steps, and this is exactly what I want to see when I assign you guys homework. We need to state our null and alternative hypothesis, but for that we need to find the claim. So your claim is going to be in this sentence, actually, the AMA conducted research found that at least 24%, so at least 24% would be 0.24 are smokers, and since these proportions, we're going to be using P. So you have found your claim. P is greater than or equal to 0.24. Well, that would actually fall right here. P is greater than or equal to 0.24. Then for your alternative, you would put P, you'd put 0.24, and you would flip the inequality, but you're going to leave off the equals to. And so I don't think you can tell very well. Actually, this darker black color is what you have to put. It's from the formulas, and then this green color is going to be changing depending on your numbers on each problem. All right, okay. So now that we know our P, so you can actually start to kind of come over here and start saying, well, now we know P is 0.24. So you can actually find Q as well by taking 1 minus 0.24, which would give you 0.76. And then if you continued reading, it said a random sample of 300 US adults. So N is your sample size. 20% said that is your p-hat, that is your sample size. So that'd be 0.20. All right, so then let's check and make sure this is good to be used. So we need to check Pn and make sure that's greater than or equal to 10, and we need to double check Qn and make sure that's greater than or equal to 10. So then Pn would be 0.24 times 300. Well, that would be 72 greater than or equal to 10. Is it? Yes. Okay, let's check the next one. All right, Qn is 0.76 times 300. Okay, well, that's actually gonna give you 228. Okay, is that greater than or equal to 10? Yes, yes it is. Okay, we're good. We can keep going. If either one of those two had given you a no, then you would have actually stopped right there. All right, so to keep going, next step is to identify your significance level. And it's right here, alpha equals 0.01. So you want to find that claim at 0.01. Then your third step would be to draw this over here. Okay, so let's draw this. 0, 1, 2, 3, -1, -2, -3. Okay, it's drawn. I drew it over here. All right, so then step number 4, find your critical values. So if you look at HA, you can see that this is a left-tailed test. And we're actually gonna say use our area is equal to alpha, which is equal to 0.01. Okay, and then from here, we're actually gonna use, hold on, I was not on the right page, but it's okay. I'll get there, right here. Here's your website. Okay, so if you're left-tailed, then you're gonna be below. You can see I was already below right here, and we're actually finding value from an area because we're given the area, okay? And then you're gonna put in your area. In this case, it is 0.0101, and we want below. So you can see that it's a left-tailed test. Well, it's gonna be below the value negative 2.326. So V0 equals, we're gonna round that to 2 decimal places, so negative 2.33. And then, oh shoot. Going back here. Alright, okay, and then going here, we're gonna come to our distribution because your step 5 is to shade your distribution area. So you need to do that by finding where, just about where about negative 2.33 is. And because this is a left-tailed test, you're gonna shade to the left of it. So this is actually up here. All right, so then you can see that this is the rejection region. And this is the non-rejection region. All right, then off to step number 6. Step number 6, find your critical value. Or not, you just found your critical value. Step number 6, find your test statistic. So Z is equal to P hat minus P divided by square root P times Q divided by N. Okay, plugging in the real numbers, our P hat is 0.20. 0.20 minus P is 0.24 divided by the square root. Okay, well, P times Q would be 0.24 times 0.76 divided by 300. All right, and then getting your calculator. Equals done. Okay, so we have 0.20 minus 0.24, and in the denominator, we have a huge square root And then I have actually another fraction in there. Okay, that would be 0.24 times 0.76 divided by 300. Okay, that gave me back negative 1.62. So then this is actually equal to negative 1.62. And then you go to step number 7. So that says decide if you reject or you fail to reject it. So we're going to actually take negative 1.62 and we're going to figure out where in the world does it land on this graph. I'm going to underline this in blue and I'm going to come over here and it's actually going to fall right in here. As you can see, it fell in the non-rejection region. So our decision for number 7 is that if it's in the non-rejection, we are going to fail to reject the null hypothesis. All right, and so then your last step is to write this in terms of everything else. Okay, define in terms of your claim. So remember that your claim was that at least 24% of US adults are smokers. You failed to reject it, so you found enough evidence. So you have evidence to support the AMA's claim. Just end it right there. So that just means that you found enough evidence to find that yes, they totally, definitely, 24% of adults are smokers. Now when you do this, I do want to see this, this value, this, and your conclusion. So I'm looking for, it looks like 7 things, but it's really 8 things. So I'm looking for your null hypothesis, your alternative hypothesis, your significance level. I want this whole graph. I want it drawn. I want it shaded. I want to know what your critical value is. I want to know what you got for your test statistic. I want to know your decision, and I want to see that sentence. You could have finished this out to say support the AMA's claim that at least 25% of US adults are smokers. You could have finished that out. All right, I think I'm going to do example number 3, and we'll not do example number, or we're going to do example number 2. I'm not going to do example number 3, but I did feel like do it, and it's on the filled out notes. Okay, so a recent poll suggests that 40% of US adults watch some type of reality TV show. We decided to test this claim and survey a random sample of 500 US adults. 230 respond that they do watch some type of reality TV show. Is there enough evidence to support this claim at your significance level equal to 0.05? Okay, so again, we need the null hypothesis and we need the alternative hypothesis. But for that, we need to find a claim. So going back to your sentence and reading it through, your claim is actually right here, suggests. That's where your claim starts. 40% of US adults watch some type of reality TV show. So they're trying to tell us that exactly 40% of US adults watch some type of TV show. Well, then that would go right here, 0.40. P equals 0.40. So I should have written that in green actually. P equals 0.40. So then your alternative hypothesis with P does not equal 0.40. Right. So we have our P equal to 0.40. We have Q, that would be 0.60. So we decided to test the claim and we took a random sample of 500 US adults. And 230 responded they do watch some type of TV show. So 200, that one didn't give us a percent, but that's okay because you just can take 200 out of 500 people. This is going to give you 0.46. And then remember, you need to double check, make sure that your N times P is greater than or equal to 10 and your N times Q is greater than or equal to 10. So n times p would give you 500 times 0.40, which is going to give you 200. And then you check, is that greater than or equal to 10? Yes, yes it is. So let's do it again. 500 times 0.60 is going to give you 300. Is that greater than or equal to 10? Yes, yes it is. Okay, so you're good. This isn't part of your 8 steps, so you just need to make sure that that goes through. All right, so then moving on to the second step, you need to state your significance level. It's right here, significance level is equal to 0.05. Okay, so then the third step is draw your standard distribution. Right, that's right there. And if you actually have plenty of room on here, you don't have to draw your graph out here. You could have drawn it right up here. I don't have that much room, so I can't draw them all down. Okay, so the fourth step is to find your critical value. So first, look at your alternative hypothesis and decide two-tailed, left-tailed, right-tailed. In this case, this is actually a two-tailed test. So we're going to use that same exact website, and we're still going to use that our area is equal to 0.01. The reason we can use that, and that's your significance of what, the reason you can still use that is because of the fact that it's going to split it up for you right here. So if you're, again, make sure you're in value from an area 0.01. If you go outside of right here, it splits it up into half on the left and the right. And so then you can see that it tells you that your critical values are actually going to be plus and minus. Actually, we need to recalculate that. Oh, I keep forgetting this is supposed to be 0.05. So putting in the correct number. There you go. It's going to be, there we go. So we have negative 1.96 and 1.96. Okay, so then you can see right here where I have to change it. So then it was a positive and a negative 1.96. So then coming over here, it would actually come right in front of this negative 2. And it's two-tailed, so you would shade to the left of this. And then it'd be right before the 2. 1.96, that's so close to 2, so I don't want to see it next to the 1. And then you shade the left. So bam, you have a two-tailed test. And then this is your rejection region. This is your rejection region. And then this is your non-rejection region. So we're going to continue with number 5. But guess what? I already did it. It's right here. So then continue with number 6. Calculate your z-statistics, which is equal to p hat minus p divided by the square root of p times q divided by n. Okay, putting in numbers, that's going to give us 0.46 minus 0.40 divided by the square root of 0.40 times 0.60 divided by 500. Right, so doing that, I'm just going to copy and paste this. Oops. So starting right here, 0.40, 0.46 minus 0.40 divided by 0.40 times 0.60 all over 500. Enter, that's going to give you 2.74. So I'm going to take my blue marker, and 2.74 is actually going to be right in here. That's 2.74. Okay, once you have that marked on your graph, then well, we fell in the rejection region this time, so we're actually going to reject that. We're going to reject the null hypothesis. So if you notice, our claim is actually our null hypothesis. So when this happens, then you have sufficient evidence to reject the claim that 40% of US adults watch reality TV shows. And so then that's all you would have to write if you project your claim. And again, remember, I'm looking for that. I'm looking for your rejection. I'm looking for this critical value, looking for your graph with it shaded in and written, looking for this critical value right here, your significance level, and both of your hypotheses. So this, all of that, this, and this. And this is everything that I want to see. So when you turn in your homework, this is the minimum of what I want. I want this, I want this, I want this. I want all of this whole entire thing graphed and looking pretty. I want you to at least put your critical value. You don't have to tell me all the other stuff on it, as long as you know. You don't have to show me this part right here. You're more than welcome to. You at least have to put that 2.74 that you got for your z-value. You have to tell me whether or not you reject, and you have to tell me your last statement as well. That's going to be about it. And then remember, I didn't do the last one on here. There's actually one more example, but it will already be done on the notes that I shared with you guys.